Okay. Thank you very much for the invitation and for the opportunity to present our proposal for the Graphene Flagship. The title of the presentation is Working Together to Combine Scientific Excellence and Technological Impacts, and I will come back to that in a moment. I would like to start with a brief introduction to graphene, a short video that some of you may have seen before. So, what is graphene?
The Simple Show explains graphene. This is graphene. Let's call him Mr. G. He is the first material that is two-dimensional. This gives him a unique set of properties. Since 1859, many scientists were looking for graphene using complex experiments. But the first crystals of graphene were discovered in 2004 using a very simple and effective method, namely ordinary Scotch tape. During Friday evening experiments in Manchester, scientists noticed small parts of graphene on the tape used to clean a graphite stone. The two scientists, Andrew Geim and Konstantin Novoselov, were awarded with the Nobel Prize in Physics 2010 for this simple but groundbreaking experiment. Thanks to the Scotch tape method, this area of science grew extremely quickly. And today, hundreds of laboratories all over the world deal with different aspects of G research. What makes Mr. G a really super material is the combination of his unique properties. G is the first 2D crystal ever known to us, the thinnest object ever obtained, and also the lightest one. G is the world's strongest material, harder than diamond, and about 300 times stronger than steel. G conducts electricity much better than copper. G is a transparent material. G is bendable and can take any form you want. And this unique super material gave birth to a new class of crystals that are also just 1 atom thin. And what's more fantastic is that these can be shuffled with each other to engineer new materials on demand to meet the special needs of different industries. All these factors move graphene swiftly from the G Research Laboratory to the G Marketplace, driven by demand from industries where such super materials are required: aerospace, automotive, electronics, energy storage, coatings and paints, communications, sensor, solar, oil, and etc. Thanks to mass production methods intensively being developed, expect to meet Mr. G in person soon.
All right. So our vision is that graphene is really the future in a pencil trace. And the flagship that we propose will create a large, focused research community that exploits the unique properties of graphene and related two-dimensional materials to create new innovations and boost economic growth. At present, there are numerous programs, both European and national, that focus on graphene research or different aspects of graphene research. Unfortunately, they are very fragmented, and what is discovered in one program gets easily forgotten and doesn't have the impact that it deserves. What we want to do is that we want to integrate the community and get rid of this fragmentation into subcritical nodes. Graphene research is still experiencing explosive growth that started in 2004. The number of published scientific articles is now well over 20 per day. And the growth in the number of patents is even more explosive, as you see on the chart on the right. This comes from the fact that graphene is an example of something that we call translational nanotechnology. Nanotechnology that has the potential of very rapidly moving from academic laboratories to the real life, to commercial applications. What makes graphene unique in this respect is that it offers possibilities in many different areas. For instance, in information and communication technology, graphene with its large conductivity and large saturation velocity offers great potential for high-performance electronics, Its flexibility gives new opportunities. The fact that it conducts light as well, it opens new optoelectronic applications. In material science, the lightness and strength of graphene can be used to create new ultralight or ultra-strong composites, for instance, for aerospace applications, as well as other new products such as conductive inks. In the energy field of application, the large surface area and large conductivity of graphene make it very attractive for batteries and supercapacitors, for cars and for portable electronic appliances. And in health, graphene-based biosensors and DNA sequencing devices open completely new possibilities. If we look at graphene funding in Europe, the graph on the left shows the total funding that different member states had invested in graphene since 2004 until September 2011 when the graph was produced. And you see that the largest players were Germany and the United Kingdom that by that time had invested about 40 million euros on graphene. These numbers have now changed. Like we heard earlier today, Poland is investing heavily on graphene, 15 million euros over 3 years. The United Kingdom is investing something like 70 million pounds on graphene. Sweden and Denmark also announced very significant investments in graphene during last year. The member state funding on graphene is now of the order of 50 million euros per year and still rapidly growing. If you look at the European funding through the European Commission, it comes from many different branches of the Commission, most importantly perhaps the European Research Council, but also NMP and ICT. And the Commission funding presently is about 18 million euros per year. It's growing at a rate about 6 million euros per year. So even the Commission funds graphene research, but in these small separated projects, which we think is not the way to go. If we look at graphene research in the world, we see that the publications are split just about equally between Europe, Asia, and the United States, about 1/3 each. And that is something that we think is rather reasonable. The problem is the bottom half of the graph, where we see exploitation of these discoveries, originally European discoveries, where we see that the patenting landscape is dominated by Asia and the United States. The European drops there are really like small planets compared to the big stars above. And that means that action is definitely needed if we want to make sure that European research is harvested in Europe. We think the recipe for success is to bring academia and industry together. The reasons for that is that graphene is a disruptive technology. It's a revolutionary change rather than an evolutionary incremental improvement of something existing. That means that there is a large financial gap and technological gap between the laboratory and marketplace. And the risk, financial risk, is far too large for any company or any country to attack individually. We want to integrate the entire value chain from materials production to components and systems in order to minimize risk and take benefit of low-hanging fruits. This is a particularly important aspect for Europe, where most companies are segmented. They deal either with materials or with components or with systems. If you look across the oceans, you find companies that themselves integrate the entire chain, which makes it much easier for them to make the transition. We think that the flagship is also the most economical way to create these chains, to eliminate the fragmentation. It's much better to make sure that efforts are not duplicated. Most of the fragmented graphene projects have somebody who does graphene production, somebody who does graphene characterization, somebody third who does whatever is specific for that project. Clearly things can be done much better. And the fact that our ideas have resonated very well with the European industries gives us great confidence that this is the way to go about it. There are companies like Airbus, BASF, Nokia, Philips, Repsol, Volvo, and many big companies that are greatly interested and participating in our project one way or the other. Plus, there are many small and medium-sized enterprises that I did not list just because the names would probably be unfamiliar to most of the audience if the company doesn't happen to be in your own country. As the video showed, graphene is really a multipotent material. It can have applications as different as coatings, as a two-dimensional Teflon, as it's sometimes put, or as new kinds of lighting devices, new kinds of sensors, batteries, and whatnot. Even a large flagship cannot accommodate all these different directions, so we have to focus. And during the 7th Framework Program, we have decided to focus on communication, on two types of communication. One is logical communication, like this new communication device, the Morph concept presented by Nokia some time ago, where you combine the flexibility and the electronic and optical functionalities of graphene to create new, more powerful and versatile information processing and communication devices. Logical communication is one part of the equation. The other part of the equation is physical communication. I have taken a picture here of a concept car, a Smart 4 Vision, produced by BASF and Daimler. I should point out that this is not particularly a graphene project. This is just a new kind of a car that they have presented as a concept. The reason why I like it is that it combines many of the possibilities where we can use graphene. It's an electric car. It needs batteries. Battery technology is something that benefits from graphene. It has integrated solar cells in the roof. Solar cell technology can also benefit from graphene as a replacement for toxic materials or as an active material itself. It turns out that this concept car that initially had nothing to do with graphene already has graphene composites in it, because completely independently of us, the companies realized that graphene was the best material for certain composites in this structure. So this is an example of the kind of system integration that we want to progress. Regarding the implementation of the graphene, the CPCSA, which is the first part to be implemented, we have had an extremely open process. Something like 550 academic and industrial groups from nearly 30 European countries expressed interest to join the flagship. We have put together an authoritative scientific and technological roadmap based on thousands of written and oral contributions. The roadmap forms the basis for the research program of the flagship. We have divided the flagship into 11 scientific and technological work packages, plus work packages on dissemination and management. Initially, the CPCSA will incorporate about 100 research groups representing about 75 legal partners, and additional partners, additional groups will enter later through a competitive call. We have also demonstrated alignment both with the national priorities, as was evident from the national investments, but also other disciplines within the European Commission. Graphical presentation or representation of the CPCSA structure is as given here, that we have a relatively lean coordination and management team, which together with this general assembly of research partners forms the management structure or the governance structure. We also have a strategic advisory council, of which we are very proud. I shall present them on the next slide. And then we have these scientific and technological work packages, where the work package leaders form the scientific panel that can then be used to integrate with the national programs, ERANET Plus, whatever there might be as an element. I already mentioned the Strategic Advisory Council. We have 9 members. We have 5 European academic researchers. 4 of them have Nobel Prizes, and all 5 are working actively on graphene research personally every day. One of the Strategic Advisory Council members, Professor André Game, is present here in this meeting today. We also have representatives of leading European companies in these communication areas, very high-level representatives from Airbus and Nokia that make sure that we have aligned the research in directions that benefit European industries. We have very strong links to international graphene programs through Professor Byung-Hee Hong from Seoul National University and Dr. Luigi Colombo from Texas Instruments. In particular, the Koreans are investing very heavily on graphene research. In the US, the investment is more fragmented, and they are trying to use, or they are using our flagship idea as a means to create something similar over there. The different work packages can be classified according to their maturity, that we have the bottom layer on which everything rests, fundamental science, materials, and studies on environmental and health effects of graphene. The next layer is component technologies, spintronics, high-speed electronics, optoelectronics, and sensors. And the top layer are these system-level applications, flexible electronics, energy applications, nanocomposites, and graphene production technologies. And you can see that the higher you move in this hierarchy, the more industry is represented. Many of the top-level packages are industry-led, whereas the bottom-level packages are academically led. And as time progresses, different concepts will move from a lower-level tier to a middle tier and to higher tier. As I mentioned, we have created an authoritative scientific and technological roadmap for the flagship program. The roadmap is also structured exactly the same way as I mentioned. We focus on materials or production technologies, we focus on components, and we focus on system integration. If you have particular questions on the roadmap, I may address them to Professor Andrea Ferrari, who's been responsible for the work package in the pilot that created the roadmap. You see that the amount of red increases as we move to the right. The red describes the industrial work share, the blue describes the academic work share. And that's natural for this kind of a project, where we really want to take something from academia to applications. Of course, we can take this high-level roadmap and break it down to specific technological targets for certain applications. I shall not spend any more time on that. This is not the right forum for that. So shortly before finishing, I'd like to repeat our mission, which is to take graphene and related layered materials from their current state of raw potential to a point where they can revolutionize multiple industries. Faster, thinner, stronger, flexible, and broadband revolution. We are convinced that this will happen. The flagship will make sure that Europe will be firmly at the heart of this process, with manifold returns of investment in terms of scientific discoveries, technological innovation, and economic exploitation. I started this presentation with a short video on graphene. I would like to conclude it with an even shorter video on the graphene flagship.
The Simple Show explains the graphene flagship. This is Peter, physicist from England. He is experimenting with graphene and other 2D crystals to find new ways to benefit from its unique properties. This is Susan, biologist from the Netherlands. She likes graphene for its biological compatibility and uses it for DNA sequencing. Anna is a chemist and works in Poland. She finds graphene extremely interesting due to its two-dimensional structure and is experimenting on its modifications. Overall, there are thousands of scientists in hundreds of labs across 29 European countries studying this exciting and most promising subject in science nowadays. David, a talented engineer, has a more practical approach to graphene. He works for a big electronics company in Finland. His boss commissioned him to develop new applications for their products. To accomplish this goal, David needs the expertise from scientists like Peter, Susan, and Anna. But where does he meet them? At the Graphene Flagship. This graphene community, initiated by the European Commission, joins both scientists and industries. Thanks to the Graphene Flagship, David can quickly build a network to scientists and hundreds of other European companies working on graphene applications. Due to this collaboration, the entire value chain, from materials production to component fabrication and systems integration, can be covered. In long-term perspective, this means new ideas in our heads, new opportunities for skilled workers, new products on the market, and finally new potential for economic growth in Europe and around the world. With people like Peter, Susan, Anna, and David, the Graphene Flagship is creating the way to our future.